In this equation, we will be using the limit of a constant, where the limit of a constant function is equal to the constant. So as a result, the limit of 5 as x approaches 2 is equal to 5. In this equation, we will be using the limit of identity, where it is equal to the number as x approaches it. So as a result, the limit of x as x approaches 2 will be result into number 2.
The limit of constant times a function. The limit of 9x as x approaches to 2. First, get the limit of the constant 9, which is 9, and multiply it to the limit of x, which is 2. Next, multiply the values. 9 times 2, the answer is 18.
The limit of the sum of two functions. Number 4. The limit of x plus 10 as x approaches 8. We can dissect the equation first, which would result to the limit of x plus the limit of 10, both of which with x as it approaches 8. Simplifying it, we'll get 8 plus 10 with a final answer of 18.
The limit of the difference of two functions. Number 5. The equation the limit of x minus 8 as x approaches 12. First, we minus the limit of x as x approaches 12 and the limit of 8 as x approaches 12. Then, 12 minus 8 equals to 4, therefore the limit is 4.
The limit of a product of two functions. The limit of 5x cubed as x approaches to 2. The first thing we do is we break down the limit of 5x cubed as x approaches to 2. After doing so, you will have to substitute x with the variable 2 since x is approaching to 2. After substituting, we will have the limit of 5x cubed as x approaches 2 equals 40.
The limit of the quotient of two functions. The limit of 3x over x plus 5 as x approaches to 1 is equals to 3 limit of x as x approaches to 1 over the limit of x plus 5 as x approaches to 1. From here, we can substitute 1 with x, which leads us to the answer 3 over 6 or 1/2.
The limit of the nth power of a function. Number 8. The limit of x plus 1 squared as x approaches 5. First, we enclose it in a parenthesis. Next, using the theorem of the limit of the sum of two functions, it will become limit of x as x approaches 5 plus limit of 1 as x approaches 5 squared. Now we apply theorem 2, which is the limit of the identity, and theorem 1, which is the limit of a constant, so it's 5 plus 1 squared, which is equal to 36, hence the answer is 36.
The limit of nth root of a positive function. Limit of a function square root of x plus 14 as x approaches 2. First, separate both f of x within the square root and then replace x with 2 as stated in the given, generating a square root of 2 plus 14, which becomes a square root of 16 and equals to 4.
Number 10. The limit of negative 9x squared minus 6x minus 9 as x approaches negative 5. First, we dissect it by separating the limit of the constant, which is negative 9. Then, we can separate the limit of the two terms negative 9x squared and negative 6x, minus the limit of 9 as x approaches negative 5. Then, we can still separate the coefficients negative 9 and 6 from their variables, making it 9 times the limit of x squared minus 6 times the limit of x minus the limit of 9. Since the coefficient 9 and the variable x are separated, we have to enclose the limit of x in a parentheses and square it. And as we notice these are limits of variables, we can directly multiply it to negative 5, giving us the answer of negative 204.